PCB prototyping best practices for fast and accurate results when designing a printed circuit board. The prototyping process is one of the most important steps. It's essential to get it right the first time so that the end product meets all of your specifications. To ensure fast and accurate results in this case, you must follow certain best practices. From choosing the right design software to properly testing the boards, we'll cover everything you need to know to get the most out of your PCB prototyping projects. Use the correct board material when it comes to PCB prototyping. Selecting the right board material is crucial. The type of material you choose can impact the board's durability and performance. Some materials are more prone to overheating or warping, while others may be more conductive or have better insulating properties. One popular option for PCB prototyping is fiberglass. It is a relatively low-cost material and can provide good insulation properties. It is also ideal for single-sided boards. However, it may not be the best option for more complex designs. For multilayered boards, you may want to consider a material like FR4. This type of material is more expensive but provides better durability and stability, which is critical for high-performance circuit boards. Before selecting your board material, you must consider the specifications of your design, including the application, environment, and electrical properties you require. Don't be afraid to consult with PC board experts to help determine which material is the best fit for your project. Using the right board material is just one of the many best practices to consider when it comes to PCB prototyping. By following these tips, you can achieve faster, more accurate outcomes and set yourself up for success in your PCB design projects. Invest in quality components when it comes to circuit board prototyping. Investing in high-quality components is crucial to achieving fast and accurate results. While it may be tempting to cut costs by using cheaper parts, this can lead to several issues down the line, from malfunctioning circuits to reduced durability. Using quality components ensures that your circuit board will function properly and last longer, saving you time and money in the long run. You must find the components that have been tested and verified to meet industry standards and specifications. Another benefit of using high-quality components is that they are less likely to fail during testing, reducing the need for repairs or replacements. This not only saves you time but also minimizes the risk of damaging other components or causing additional issues with the circuit board. Make sure your board design is complete and accurate before starting your PCB prototyping project. You must ensure that your board design is complete and accurate. This step may seem obvious, but it is often overlooked, resulting in errors and the waste of time and money. Start by double-checking your design for errors, missing connections, or any other issues. Use reliable design software and go over your schematic and layout files thoroughly. Get a second pair of eyes to review your design before moving forward with prototyping. Another best practice is to perform a design rule check, DRC. This automated check ensures that your board meets the minimum manufacturing requirements. A DRC can identify potential errors, such as overlapping pads, inconsistent track widths, or drill holes that are too small or too close to each other. If your board design has multiple layers, it is crucial to verify that your stack-up is correct and that the signal integrity is maintained. You can use a simulation tool to predict and optimize the electrical performance of your board. Follow the datasheet. Following the datasheet is essential to achieving accurate and reliable results while PCB prototyping. The datasheet contains crucial information about the board's electrical characteristics, material properties, and manufacturing specifications. The datasheet typically contains the following information: PCB layer stack up and dimensions, minimum and maximum board thickness, trace and via size, spacing, and clearance, impedance requirements, material composition and properties, surface finish options, solder mask and silk screen specifications, thermal management guidelines. Such a practice can ensure that your PCB prototype meets the manufacturer's specifications, as well as any relevant industry standards. Failure to follow the data sheet can result in design flaws, manufacturing errors, and functionality issues. Moreover, you should communicate with your PCB manufacturer if you have any questions or concerns about the data sheet. A reputable manufacturer has a team of experts who can guide you throughout the prototyping process. So, following the data sheet is the best practice for fast and accurate PCB prototyping. Make test points accessible. Make sure that the test points are easily accessible. This helps have easy testing and debugging of the PCB during the prototype stage. Test points are small metal points on the board where you can attach the testing equipment to measure the voltage. You can find them near components to be tested. By making them easily accessible, you can avoid having to take the board apart or maneuver equipment to access them. You should consider this factor during the design phase. Ideally, you should choose unobstructed areas. You should also consider adding extra test points to ensure thorough testing of the entire board. Moreover, you should consider the size and type of test points to use. Small test points can be difficult to use, while larger test points can take up more space on the board. You should also consider the technology, such as surface mount or through-hole. By making test points accessible during the prototyping phase, you can save time and ensure accurate results. It can also help to identify any issues with the board early on in the development process, helping in easier debugging and revisions. Consider your assembly options. After the PCB prototype process, comes the assembly. There are several assembly options available, and you should consider which one is best for your particular project. One option is hand assembly, which involves soldering components to the board by hand. This method is cost-effective and works well for small-scale production runs, but it is time-consuming and may result in inconsistencies. Another option is automated PCB assembly, which involves using machines to place components onto the board. This method is efficient and accurate, but it may be more expensive and more suitable for larger production runs. You should also consider whether you want your board to be surface mount or through-hole. Surface mount components are smaller and lighter, making them ideal for compact designs. However, through-hole components can provide a stronger mechanical bond and are ideal for larger components or those that require high voltage. Make sure to consider the assembly options before finalizing your PCB design and prototyping process. This will help ensure that the end product meets your expectations and requirements. Don't forget the silk screen when it comes to printed circuit board prototyping. People often overlook the importance of the silk screen. The silk screen is the layer of ink on top of the PCB that indicates component placement, orientation, and other important information. It may seem like a minor detail, but an accurate silk screen can save a lot of time and confusion during the assembly process. First and foremost, make sure your silk screen is complete. This means double-checking that all component labels are correct and aligned properly with their respective pads. Make sure there are no overlapping labels or missing information. Next, consider the size and color of the silk screen. A too small or too light font may be difficult to read, especially for those with vision impairments. Conversely, a font that is too large or too dark can clutter the board. Finally, be mindful of the placement of the silk screen. It should not cover up any important traces or pads. Besides, it should not interfere with any assembly processes or inspection. Final thoughts: prototyping printed circuit boards is a complex and time-consuming process, but with the right techniques, it doesn't have to be. If you want to ensure fast and accurate results, you must follow best practices. In this case, investing in quality components is an essential step in achieving fast and accurate PCB prototyping outcomes. Don't compromise on quality to save a few bucks, as it will end up costing you more in the long run. Also, make sure that your board design is complete and accurate, as it will save you time and money. Before starting your PCB prototype, you should thoroughly review and understand the data sheet provided by the manufacturer. It ensures that your design meets the manufacturer's specifications and industry standards, preventing errors and functionality issues. Also, don't hesitate to consult with your prototype PCB manufacturer if you have any concerns about the data sheet. Also, remember the importance of the silk screen when prototyping your PCB. A well-designed silk screen can improve the overall functionality and aesthetics of the PCB. Make sure to choose the right font and color, and be mindful of placement. A little attention to detail can go a long way in the success of your PCB prototyping project. Would like to know more about PCB prototyping or printed circuit board assembly? Email us at sales@nconline.com. That's sales@nconline.com. That's